We have been solving exponential equations and using logarithms to help us solve those things. We've also been talking about compounded interest. So now we're talking specifically about compounded continuously. Interest that's not compounded over a certain time period per year, it is compounded constantly, continuously. This is many times used in business and allows us to understand how we can double our money and how much money, how long it might take us to accumulate a certain amount of money. So be sure that when you're looking at the problems for these, that you are reading very carefully and that you look for the word continuously. So this new formula is going to be P of t equals P sub 0 e to the RT. And different people write this different ways. More simply, you could just write this PE to the RT or PERT. A lot of people use that to memorize. This P sub 0 is just your initial principal, how much you're starting with. And then your function, P of t, is that side would be how much you end up with, your end amount after so many years. E is just E, and R is your rate in decimals. T is your time in years. So many of these variables that we've been doing before still are valid. We just have a different means, and this E is now thrown in there, okay? The other concept you need to know is doubling time. Doubling time allows us to calculate how long it would take our money to double. And regardless of how much money you start with, the only thing that it comes into play when we're talking about doubling time is the rate. So this is why people get really excited or really try to get interest rates that are very low for mortgages or very high for investments, so that they can double their money quicker or pay off their mortgage quicker. And it is directly related to the rate. Notice that in this formula for doubling time, you just have the natural log of 2, so that's your double amount, divided by your rate in decimals. That's it. So the amount of money you invest doesn't matter, only the interest rate. All right, so let's look at this problem. Suppose that $15,000 is invested at an interest rate of 5.7% per year, compounded continuously. Let's first find just the growth function. Notice that in our problem, we are not given the time, how long it's invested for. So we just want to write this function as a function of time, leaving t as t. So our P sub 0 in this will be the amount we've put in, our principal. So we'll have 15,000 E, R, E to the R. So R in this problem, 5.7% is going to be 0.057. And then T is just T. So that's how you would write this function. P of T equals 15,000 e to the 0.057 t. Now, if you're struggling with how to write this, I would suggest taking 5.7 and dividing by 100. This kind of looks like a 100. It helps me out sometimes, or it used to anyway. All right, now the part B, it's saying find the balance after 5 years. So it's giving you a time frame, and we're going to substitute that into the value for t. So 15,000, let's do our work over here. 15,000 E, and be very careful when I put this in the calculator, I'm going to put parentheses around this. So I've got 0.057 times, I'm using that as a times, T, and T in this problem is 5. So let's put this in the calculator and see what we get. So we have 15,000 times E, parentheses, 0.057 times 5. Okay, I don't know if you can see that. There we go. So our money amount that we have here is $19,946.43. Now, we are doing 2 decimals because this is money. So you don't, when you go to the store, they don't round up to a whole number, and they're not giving you 5 decimals for your total amount. They're going to give you 2 decimals. Okay, so that's what we're going to round to. And this makes sense because if we start with 15,000, it makes sense that we would make $4,946.43. So our total here is $19,946.43. That's a realistic amount. And you do want to make sure that this is realistic. If you were to get 8,000 and you started with 15, that would not make sense. So you would want to go back and reevaluate. All right, and lastly, when will the investment double? In what year is that? So how many years does it take? And they did not give us a starting year, so we're just going to calculate the total number of years. Your problem, you may have a starting year, so you would calculate the total number of years and then add it to the year that you started investing. So for this problem, when will the investment double? We're going to use this formula. X equals natural log of 2 over R. Again, the only thing that matters is the rates. So we've got natural log of 2 over 0.057. Let's put that in the calculator and see what we get. So I have 12.16. There's not a decimal here that they're telling us to round to, but just read very carefully in your problems of what it says. What this is really saying is it's going to take 12 years plus a little more for my money to double. If I started out with $15,000 invested at a rate of 5.7% per year. Okay? So to give you an example, if I started out in the year 2010 and wanted to know the year that my money would double, I would take 2010, add 12, and I would get 2022. That would be the year my money doubled. So that's an example of what it would look like if years are involved, if the actual year is involved. So that was compounded continuously and doubling time.